Hello everyone, welcome to my lecture on catalysis. Normally, chemistry is mainly dealing with a lot of chemical reactions. What is a chemical reaction? When A plus B, let us assume these are the reactants. They are giving you C plus D. These are the products. Reactant gives product or products. This is the simple syntax for any chemical reaction. Reactants are giving products. For any reactant to convert into product, they have to overcome certain energy barrier. Let us assume this is the graph, this is the energy, this is the reaction progress. See, the energy of reactant is here, energy of product is here. If the reactant is going to be converted into product, it has to overcome certain energy barrier. This is the energy. This is the highest energy it has to surmount, it has to cross over. For crossing over this energy, to overcome the energy barrier, it has to work. It has to spend some energy. It has to take some time. When energy barrier is very high, the time taken by the reactant to be converted into product will be more. At the same time, there are certain chemicals. Say for example, I am adding a chemical X. The X is changing the rate of the reaction. The X is changing the rate of the reaction. Any chemical substance that alters the rate of the reaction is known as catalyst. The process is known as catalysis. What is the actual mechanism? When you are using the catalyst, it will reduce the energy barrier. This is known as the activation energy or the energy barrier. See, without catalyst, the energy barrier, activation energy is very high. It requires more time to cross over this, to surmount this energy barrier. When we are using a catalyst, it reduces the energy barrier. The same reactant is converted into product, but without catalyst, or this is the energy of activation, this is the energy of activation with catalyst. When you are using that catalytic substance, that will reduce the energy barrier. Obviously, it will be completed within a short span of time. This is the concept of catalysis. Technically speaking, catalyst not necessarily speed up the reaction. The actual definition is the substance which alters the rate of the reaction. It goes the other way around also. It can reduce the speed also, it can increase the speed also. But in most of the industrial applications, we are mainly focusing on increasing the rate of the reaction. Therefore, in a normal sense, we can say catalyst is the substance which speed up the reaction, which alters positively the reaction speed, is known as catalyst. As I said, sometimes, most of the time, they are increasing the speed of the reaction. They are known as positive catalyst. What are positive catalysts? The substances which are increasing the speed of the reaction are known as positive catalyst. Most of the 90% of the industrial catalysts are positive catalyst. But there are certain substances which are capable of pull down the speed of the reaction. They are known as negative catalyst. You may wonder, what is the need of slow down the reaction? Obviously, we are always looking for the increased speed of the reaction. What is the need of decreasing the speed of the reaction? Does it make any sense? Yeah, it is also having some of the applications. For example, we are using hydrogen peroxide liquid. Hydrogen peroxide, it is an antiseptic and then cleansing agent in pharmaceutical industries. The shelf life of hydrogen peroxide is comparatively less. When it is exposed to the atmosphere, when it is not kept in the tight container, what will happen? It will be converted into water and oxygen. the antiseptic and cleansing property of hydrogen peroxide will be lost. This is the decomposition reaction. To slow down of O2. To slow down the reaction, we can add a minimum of dilute sulfuric acid. The dilute sulfuric acid slows down the process of decomposition of hydrogen peroxide. Therefore, this can be known as a negative catalyst. Then what is positive catalyst? Most of the examples we are encountering in industries and applied chemistry are coming under the domain of positive catalyst only. Simple example, Haber's process. Nitrogen plus hydrogen to form ammonia. Nitrogen and hydrogen to form ammonia, we can use platinum. The platinum catalyst increases the speed of the reaction. When the rate of the reaction is speed up by any catalyst, it is positive catalyst. If it is slowed down by the presence of a catalyst, it is known as negative catalyst. This is the basic introduction. So, what is a catalyst? A catalyst is the substance used to alter the rate of the reaction is known as catalyst. The process is known as catalysis. If it increases the rate of the reaction, it is positive catalyst. If it decreases the rate of the reaction, negative catalyst. Fine. Then, based on the physical nature of the reactant and product, based on the physical nature of the reactant and product, the catalysis can be classified into two major categories. What are they? Number 1, homogeneous catalysis. Number 2, heterogeneous catalysis. The name itself suggests, right? Homogeneous means similar, heterogeneous means different. Look at this example. This is the reactant. Nitrogen and hydrogen are the reactants. What is the state of nitrogen? Gaseous phase. What is the phase of hydrogen? Gaseous phase. The reactants are in the gaseous phase. How about platinum? Is it in gaseous phase? A definite no. What should be? It is in the solid phase. The reactants are gaseous phase. The catalyst is in solid phase. They are not in same phase. They are coming under the domain of heterogeneous catalysis. Look at this one, hydrogen peroxide. What is the phase of hydrogen peroxide? It is in liquid, right? To minimize the decomposition of hydrogen peroxide, we are using one catalyst. Though it is negative catalyst, what is the state of dilute sulfuric acid? It is also in liquid. So, this is also a liquid, this is also a liquid. When the reactant and the catalyst are in the same phase, they are known to be homogeneous catalysis. Majority of the catalyst, what we are using it in industries are heterogeneous catalysis. What are the advantages of heterogeneous catalysis? We can ponder over that point, right? This is sulfuric acid, this is hydrogen peroxide, they are in same state. The regenerating your catalyst will not be that much an easy task, because both are in the similar state that requires some distillation or some special techniques of separation. On the other hand, if you are looking at nitrogen and platinum, nitrogen is in gaseous phase and platinum is in solid phase, it is very easy for you to recover this kind of catalyst, right? And one more thing, the thermal stability. The thermal stability of the heterogeneous catalyst is comparatively higher when you are comparing with your homogeneous. Therefore, it is always preferred to use this kind of heterogeneous catalysis. Okay, these are the basic introduction to catalyst. What we have seen so far, what is catalyst? The substance used to alter the rate of the reaction is known as catalyst. If it increases the rate of the reaction, it is positive. If it decreases the rate of the reaction, negative catalyst. What is the mechanism? Essentially, when a reactant is going to be converted into a product, it has to surmount a certain amount of energy barrier. When you are using catalyst, it brings down the energy barrier so that it will be easy for the reactant to pass through the energy barrier to be converted into the product. That is the simplest way. And the second level, what are the various types of catalysis? Based on the physical states of your reactant and the catalyst, we can classify them into homogeneous catalysis and heterogeneous catalysis. In homogeneous, both your reactant and your catalyst will be in the same state. Heterogeneous catalysis, the reactants and the catalyst will be in the different phases. Then, what are the basic characteristics or salient features of catalyst? If you want to classify any substance as the catalyst, it should fulfill certain standards, the basic criteria, the basic requirement, the salient feature you can mention that. What are they? The very first thing already we mentioned, the physical nature may change, but the chemical properties should not be altered. Say for example, we are having some perchlorate decomposition, potassium chlorate decomposition. We are using manganese oxide, MnO2. Initially, we are using that manganese oxide in the granular form. After the reaction, the granular MnO2 will be converted into powdered form. It is permitted. Initially, we are having MnO2 in the granular form. After the reaction, we are having in the powdered form. At the same time, the chemical property should not be changing. See, if you are having manganese oxide, it will not be converted into oxygen and manganese, or it will not be converted into potassium oxide, because we are using potassium chlorate. Along with the potassium chloride, it should not react. It should not be converted into manganese chloride or potassium oxide. Nothing, it should be changing. But it is permitted only in its physical nature. The granular MnO2 can be converted into powdered MnO2. That is the first thing. Number two, it should not initiate any reaction, or it cannot initiate any reaction. If there are certain reactions which are known as forbidden reactions, permissible reaction and forbidden reactions are there, or there are certain stoichiometric proportions under which the reaction may not take place. In such conditions, even if you are using catalyst, it cannot initiate impossible reaction. Only the speed can be altered or the rate can be altered, not about the nature of the reaction. That is the second thing. Number three, the equilibrium state. There are certain reactions where we can say forward reaction and reverse reaction. By using the catalyst, you can't alter the direction of the reaction. The equilibrium should not be altered by using catalyst. If it is so, that might be because of the inclusion of the catalyst in the reaction. When any substance that is included in the reaction may not be considered as catalyst. So that is also very important key feature. The catalyst, as a catalyst, it should not alter the equilibrium of a substance. Right. And number four, you have to use a minimum quantity. Most of the inorganic reactions, almost all the inorganic reactions are using very minimal quantity of catalyst. Compared with the quantity of your reactant, the catalyst must be in a very minimal quantity. Exceptions are there. Say for example, considering that organic reactions, we are having the Friedel-Crafts reaction, right? What is Friedel-Crafts reaction? Alkylation of benzene. I am having benzene. The benzene has to be alkylated. What is the alkylating agent? You can have any ethyl chloride or any alkyl halide. What will happen? One of the hydrogen will be substituted by ethyl group. So you will be having ethyl benzene. And HCl in presence of aluminum chloride. What is the Friedel-Crafts catalyst? Aluminum chloride. Aluminum chloride, if you are using it in a very smaller quantity, the reaction will not be speed up. You have to use a maximum quantity. Say for example, if you are taking 100 grams of your benzene, at least 30 grams of aluminum chloride is required. That is the key reagent. Normally, in most of the inorganic reactions, we can use a minimal quantity of catalyst. In organic, most of the organic reactions are requiring little higher quantity of your catalyst. So what are the first four things we have discussed? Physical nature can be changed, chemical cannot be changed. The catalyst cannot initiate any reaction. It can only speed up or slow down the reaction. The equilibrium cannot be changed. Number four, minimum quantity is sufficient for most of the inorganic reactions, with the very few exceptions like Friedel-Crafts reaction. Right. Then the very important property of catalyst is they are very specific in nature. Various types of catalyst will give you various types of product. We have mentioned the catalyst will increase the speed of the reaction. No second thought about that, no doubt about that. On the other hand, if you are not using the proper catalyst for a particular reaction, you may end up with obtaining some unwanted or unexpected product. Let us have some example. I am having ethanol. They are very specific in nature. Number 5, they are very specific in nature. I am having ethyl alcohol. When you are using aluminum oxide, it is also a catalyst. Leah, C2H5OH, Al2O3, aluminum oxide is there. When you are using this aluminum oxide, the product we obtained is C2H4 plus water. What is C2H4? Ethylene. When you are using aluminum, it is aluminum oxide, it is also a catalyst. Ethanol is the reactant, the starting material. When you are using aluminum oxide as the catalyst, you will be getting ethylene and water. On the other hand, if you are using copper catalyst, you will be getting aldehyde material, CH3CHO. Guess what is the name? CH3CHO. CH3O is aldehyde, the first aldehyde, or sorry, second aldehyde, CH3CHO acetaldehyde. Acetaldehyde and H2 will be produced. So, if you are changing the catalyst, the product may also change. That shows the catalysts are very specific in nature. The catalysts are very specific in nature. And number 6, always the catalysts are having higher efficiency in powdered state. Catalysts are having higher efficiency in powdered state. Why so? Why not in the solid state? The reason is, if you are having a catalyst, what is the basic mechanism already we mentioned? It is reducing the energy barrier, and then it will be acting as the activation sites. The reactants will be adsorbed on the solid surface. When the reactants are coming closer, they will be reacting very faster. Let us assume we are having a nickel catalyst. Nickel, the nickel is in the solid state. Let us assume we are having nickel in the solid state. How many nickel atoms are there? 4 nickel atoms. How many active sites are here? Let us count. 1, 2, 3, 4, 5, 6, 7, 8. If I am having nickel in the very solid state, in the concrete state, we are having 8 active sites. That means there are 8 active sites are available, 8 reactants can occupy this area, and further reactions will be processed. Now what I am going to do, I am going to powder this. I am going to cut the bonds and then I am making it as the powder. Nickel, when powdered, it will be forming nickel. 4 active sites for each atom. How many nickel are here? 4. Therefore, 1, 2, 3, 4. How many times I can have? 4 times. Because here 4 nickel in the concrete state. When it is powdered, it will be giving nickel 4 active site into 4. 4 into 4, 16. I am not at all adding any extra nickel. I am using the same quantity of nickel, but nickel in the solid state, nickel in the powdered state. In this level, it can accommodate 8 external molecules or external atoms. Here, 16 atoms can be accommodated. That is twice the amount of the energy. The efficiency is almost doubled. You can imagine, I have taken only 4 nickel example. What if it will be having 6 or 8 or 12 or 24? Proportionately, the amount of the accommodation capability will also be increasing. This is how always the catalysts are having higher efficiency in the powdered state. Fine, okay. And the last 2 points are there. All the catalysts are having a very optimal temperatures. At a certain particular temperature or certain particular pH, they are showing their higher efficiency. It is known as optimal pH and optimal temperature. For example, enzymes. Enzymes are also biological catalyst. Whenever we are having some fever or whenever we are feeling sick, we may not feel that much of hungry. What is the reason? Because the enzymes that are inside our digestive system, they may not be acting properly because our body temperature is getting shooting up. Similarly, when we are having some acidity or when we are having some alkalinity in our blood, that will also effectively affect our digestive system because the pH of the enzyme, optimal pH is getting disturbed. These are a simple example. At a given particular temperature and pH, the enzymes as well the catalyst are showing higher efficiency, that is known as optimal conditions, optimal temperature and optimal pH. And the last 2 points, in presence of certain other catalyst or in presence of certain other elements, the catalyst will show enhanced catalytic activity. Say for example, I am having platinum. The platinum catalyst, when it is added with little bit of molybdenum, the catalytic activity of platinum is increased. These are known as catalytic promoter. This is known as catalytic promoter. Similarly, certain activities of certain catalyst will be hindered, disturbed by the presence of other substances. For example, when platinum is in presence of like arsenic, the arsenic is acting as the catalytic poison. It will occupy all the reactive sites. Say for example, the nickel is having reactive sites, right? The reactive sites are meant for the reactants to get accommodated. But before the reactants come and getting accommodated here, this arsenic will go and occupy all the available sites so that the further reaction may be hindered. That the platinum activity is getting decreased. They are known as catalytic poison. Let us reconsolidate. We studied about what is catalyst, what is positive catalyst, what is negative catalyst, what is the mechanism of catalysis, what is homogeneous catalysis, what is heterogeneous catalysis, and the comparison. And finally, we discussed about what are the salient features of catalysis. We started with the catalyst can have physical conversion. The state of the physical state may be changing, but know the chemical composition. Number 2, it cannot initiate any kind of reactions. The equilibrium process or the equilibrium state cannot be reversed. It should be used in a very minimum quantity with a very few exceptions like Friedel-Crafts reaction. And they are very specific in nature, as we have seen in the examples of ethanol. In presence of aluminum oxide, it forms ethane. In presence of copper, it forms acetaldehyde. And then they are showing maximum activity in the powdered state. Simple example we have taken as the solid nickel and powdered nickel and how the efficiency is enhanced we have seen. And all the catalysts, may it be the chemical catalyst or the biological catalyst or enzymes, they are having a very good activity at a particular temperature and pH known as optimal temperature and optimal pH. And there are certain substances whose presence will enhance the activity of catalyst, which are known as catalytic promoter. It goes the other way around, as we mentioned, there are certain chemicals which are pulling down the efficiency of the catalyst, which are known as catalytic poison. With that, we are completing the basic introduction to catalysis. Thank you all.